Hi, folks. Today we're going to be talking about Venn diagrams and Euler diagrams. And so a Venn diagram is a way of organizing information. And I'm guessing most folks have probably seen this before. Typically, it's comprised of 2 or 3 circles. A Venn diagram will show all possible overlaps, even if they are empty. And so in this case, we have dolphins and fish. And so dolphins breathe air, have live birth, and are warm-blooded. They also swim, are aquatic, and have fins. Fish, they breathe water, lay eggs, and are cold-blooded, but they do swim, are aquatic, and have fins. In this case, we can see what the two things have in common and what they do not have in common. That's the whole point of a Venn diagram. When comparing two sets A and B, a Venn diagram has 4 different regions. And we can kind of see it here. We have the stuff which is in A but not in B. We have the stuff which is in B but not in A. We have the stuff which is in both A and B. And then we have the stuff which is not in A or in B. That's usually on the outside. We have set theory ways of writing any combination of these objects. And so if you want the stuff that's on the outside, as well as the stuff in the intersection and the stuff over in B, but not in A, and we really just don't want to include the stuff which is not, or which is in A, then we can do that. We could do A complement union B. And so there are a lot of different ways we can represent the combinations of these 4 regions. We can also compare more things. And so when comparing 3 sets, there are 8 different regions that occur, and we can visualize them fairly clearly here. Here we have things that are only in A. Here are things which are in A, B, and C. Here are things that are in A and B, but not in C. Here's things that are not in anything. And so we can put all of the information in here. If we wanted to compare 4 or 5 different sets, it is possible to do it with a Venn diagram, but often it's not very practical. Usually you'll use ellipses or something else, but more often than not, you'll use some other strategy for comparing the information. Here's practice. Construct a Venn diagram comparing the structures in these 3 sets. And so if you'd like, pause the video and give it a shot. And let's see what we get. And so in this case, we have set A, which has -5, square root of 2, e, I, and pi. For set B, it has A, E, I, O, and U. And for set C, it has H, O, R, S, E. And so in this case, we can see what A and B have in common. It would be I and E. We can see what B and C have in common. It would be E and O. We can see what A and C have in common. It's just the E. And we can also see that there's this one area which is empty. In this case, this empty spot would be things which are in A and C, but not in B. Well, there's nothing which meets that criteria. If we did not want to show that empty spot, we would use what's called an Euler diagram. And so an Euler diagram is very similar to a Venn diagram. In a Venn diagram, you must show all the possible overlaps, even if some of the overlaps are empty. In an Euler diagram, we only show the regions which are non-empty. If 2 sets have nothing in common, we do not show them as having an overlap. Consider the previous example. Instead of drawing it with an empty space, we could draw it like we did here. And so note that this set and this set, or this diagram, are representing the exact same information, but this one is showing that A and C have no overlap, which is not in common with B. The value of an Euler diagram? Well, Euler diagrams can be more versatile than Venn diagrams. We can demonstrate more relationships, such as when one set is wholly within another set, or when two sets are completely disjoint. You can also feel a little bit freer to use shapes other than circles. For example, the Euler diagram here is demonstrating 10 different number sets and how they are related to one another. You could not do that with a standard Venn diagram. Here's another example. This one, it's not quite an Euler diagram, though. There are a couple of empty spots. But note what it's comparing is it's comparing the British Isles, the British Islands, the United Kingdom, Great Britain, and Ireland. And so we have 5 different sets, and we want to know how they are related to one another. Well, without this diagram, I would probably have a very difficult time distinguishing them. But with this, it's fairly easy to see. We can see that Ireland is broken into Northern Ireland and the state of Ireland. We have Great Britain, which includes Scotland, Wales, and England. But there's other islands as well, which include the Isle of Man, Jersey, and Guernsey. North Ireland, Scotland, Wales, and England form the United Kingdom, and altogether it forms the British Isles. And so, yeah, using this diagram, we can figure that out fairly quickly. Again, though, it's not quite an Euler diagram, is it? Because we do have some empty spaces here. We have this space here, which seems empty, and we have this space here, which seems empty. But it is very similar to an Euler diagram. Here's a practice. Construct an Euler diagram comparing the structures in these 5 sets. 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 2, 3, 5, 7, 11, 9, and 11. If you'd like, give it a shot. See if you can create an Euler diagram that shows all 5 of these sets and how they interact with one another. And here is the answer. And so if you look at this, we have set A, B, and C all have 2 in common. A and B have 4 and 2 in common, while A and C have 2, 3, and 5 in common. A has 1, 2, 3, 4, 5. B has 2, 4, 6, 8, 10. C has 2, 3, 5, 7, 11. And then we have E, which is just the set containing 11, and then D, which is just the set containing 9. 9 is just disjoint from everything else. And so using this Euler diagram, we're able to clearly visualize how everything is connected. Final thoughts. The Venn diagrams and Euler diagrams are a great tool for set theory, but also a great tool to organize information. Have you used them in your work or life? How could you use them to organize structures you deal with regularly? We're soon going to be using them to do a lot of math, in particular topology. Topology is more or less defined in terms of the idea of Venn diagrams. Think of an atlas that contains all of the maps of the world. You could determine a lot about the structure of the world without needing to know if the world is shaped like an apple, a sphere, or a pear. And that's really the power of topology, and we need Venn diagrams to get there. One final thought. When we're talking about Venn diagrams or Euler diagrams, we will almost always refer to them as Venn diagrams because Euler has everything named after him. And if you say a Venn diagram, anyone is going to know exactly what you're talking about. With that, I'll let you get to work exploring where you find Venn diagrams in the real world. Good luck, folks.